This is gonna be so great. Oh my gosh, parkour. Okay, physics notes. I'm putting the physics notes right here. Let's parkour. Let's do it. Oh, oh,
Man, that was such a good time.
yeah. What? Where are our physics notes?
My gosh, they're gone.
They're past the test tomorrow.
I know.
We need those.
What's this?
Open it.
Your notes are safe, but they're not here. Notes that you desire have disappeared. Are you ready to find your notes and save your name? At first, you will have to play a little game. The rule to this game is X marks the spot. You will follow it whether you know it or not. Road, rock, or any form of terrain will be a wall to stop you from making your gain. You now have the answer to my inquisition, but first, you must find my position.
Wow, this guy's impossible. I mean, how are we supposed to figure this out?
Wait, it's all here.
What do you mean?
Well, his answer must be somewhere in this riddle. I mean, you remember Mr. Tolberg's physics class?
Yeah.
Well, position is just someone at a certain place with a certain direction. So,
Right.
if you take that and apply it here, look, see this line right here? See, he's mentioning different types of terrain, but
Yeah?
I don't really get it. There's rocks and roads everywhere.
Wait, you're onto something. Look, maybe it doesn't connect metaphorically, but physically. Now, look how he says these lines. Rock is the first word of this sentence, and then wall is the first word of this sentence. Rock, wall.
Whoa, you're right. Hold on. Read the first words of 1 through 7 for me.
Notes are at the rock wall. That's where he is. That's his position.
Now remember, position is a certain distance with a certain direction.
Right.
And we are the point of reference, or where that point is measured from. Mr. Tolberg's teaching.
Mr. Tolbert.
Yeah, funny guy. So, the rock wall must be 50 yards in the negative direction, and it's negative because it's left from 0, or where we are right now.
Right.
But why are we standing around? Let's go!
Hey, that's him. Hand over our notes.
What good would that be? I still have a couple of tricks up my sleeve. Now listen carefully. The area that you're in is very widely spaced, but now you must find the amount you have displaced. Once you find your answers from the top, you must find your distance, and do not stop. Once your answers are found and compared, the location of your notes will be shared.
What the heck was that?
I don't know. But he did tell us exactly what to do. Again.
Said something about displacement? What does that mean?
Displacement is the change in position. So, essentially, displacement is the final position minus the initial position.
Great that you know that, but how does that help us?
I don't know.
Wait. Hold on. Doesn't that look like a line to you?
Well, yeah, but
He said that we would find our answers from a top. Maybe these lines draw a bigger picture.
it's worth a try. Let's get up above and see what it looks like.
What is it?
It's the symbol delta x, the denotation for displacement. How far do we travel to get here?
50 meters in the negative direction.
Take our position right now, 50 meters, okay? Subtract it from our initial position, which was 0. Negative 50 is our displacement.
But he said something else about distance?
Distance is similar, but it's not the same. Distance is how far you've traveled, but regardless of your direction. So we've traveled 50 meters.
And negative 50. Hold
So-
on. You add those two together and you get 0.
Negative 50 and 50 is 0 meters.
We need
Wait.
to go back to where we started.
No. 0, as in right here. Maybe it's right here.
Look at the delta.
Well, what about it?
Come on. It isn't just a delta X. It seems to be pointing somewhere, like an arrow.
Of course, it's pointing over there. That's where we need to go.
I give you two congratulations on coming this far. I will say that you were almost there, but you must complete one more challenge, and I shall give you a map. Your only clue is that you must journey in a positive direction at the same speed, and it ends at 0. But now you will be timed. You have 2 minutes to get there, or there will be no notes left to see.
Did it again!
Again! Oh, look, a map.
We don't have enough time to figure this out.
Maybe we do. He said it's in a positive direction, right?
Yeah, right.
Well, we've only been going away from 0. We need to start going towards it. But how do we do that? How do we find 0?
I think I know. Look, the roads look just like a displacement time graph.
Really?
Yeah, look, here's the y-axis, or the displacement, and here is the x-axis.
Or the
Or the
time
time
travel, right.
Perfect. Mr. Tolbert taught us this. This is where we started.
Right.
This is the rock wall. And this is where we are now.
Oh, so if you start from 0, we were traveling in a negative direction.
Right. That's this.
Why is it straight?
Well, because we have to connect and go in a straight line. The slope determines our velocity.
No, we spent some time waiting here. So we didn't actually move any time. So that means if we weren't moving, the graph was at 0. Movement the whole time. So it was only going in a straight line. We need to find the y-intercept, or where the line crosses the y-axis, because that will tell us the distance that we were at when the time was 0. It looks like the y-intercept is at 0 meters. Draw it out. Okay. So 0 meters, we were at 0 minutes, we were at 0 meters. Then we ran this way for about 50 meters. And then we stood here. And then we waited here for a few minutes so the line is straight because time passed, but no distance was passed. Now, then we waited a few minutes and then we moved in this direction.
Why this angle?
It has to do with slope. The slope is the unit of the y-axis per the unit of the x-axis. In this case, when the distance traveled was 3 meters, the time changes by 1 second. Therefore, we were traveling here at 3 meters per second. So now we're not moving here, but the time is still going on. So the line is horizontal because no change in y occurred. Anyways, after that we ran quite fast. It was about 100 meters in about 25 seconds. So that's 4 meters per second. You can see how the slope is steeper than it is over here. That's because we were traveling at a faster speed. Now we have to get back to 0. So the displacement will be positive because we will be at 0, and 0 minus a negative number is always positive.
And 0 is where we started,
Exactly.
due to the reference point.
So we need to get from here back to 0.
We don't have time for this. Let's figure out where we need to go, and let's go.
On the map, we're right here. This is where we need to go. That's about 70 meters back to 0. If we have this amount of time, that's about 4 meters every 1 second. Sound good?
We can do that.
We can do that. Let's go.
Well done, gentlemen. Here is your rule.
Yes.
What?
There's nothing in here. How are we supposed to pass the test with no notes?
You just did.
What do you mean?
Mr. Tolbert!
And I must say, that was some exceptional work. You boys both did an impressive job.
So you're telling me that this was all just a test?
This was the test. You both passed with flying colors. Actually, it's safe to say, you boys didn't even need those notes.